Hello, welcome to an Introduction to Java Programming, an online workshop presented by Pasadena City College as a part of the STEM at Home series. My name is Kanchan Kaur and I will be leading today's workshop. For you, you get to be a ninja today, using your home as a dojo. So let's begin your training. Before we begin, here is a quick summary of what we will be covering. First, we will do a quick introduction where you will get to know about me, your STEAM ambassador, and why we are learning about computer science. Next, we will learn about what computer science is, allowing us to start diving into the fundamental concepts of Java. Then we will begin coding. We will be doing two projects where we will be programming a basic calculator and then a tic-tac-toe game. Please note that because there are so many interesting topics to cover, we will be splitting this workshop into two sessions, meaning we will do the calculator project in this video and the next video will cover the tic-tac-toe game. So let's do a quick preview of what we are working towards. This is a quick example of the calculator project that we will be doing later in this video. Notice how the program is prompting the user to input certain values, then processing it, and eventually outputting the final value after the calculation. The second project that we will be doing is a tic-tac-toe game, which again we will cover in the second video, which will be part of today's lesson. Lastly, we will look into a career in technology, specifically in computer science. We will see the potential possibilities available with a computer science degree. So, let me begin by introducing myself. Once again, my name is Kanchan Kaur, and today I will be your sensei. I am a first-year computer science major, and I absolutely love it. I chose to study computer science because I think it's really cool to see how it's such a growing field and how it is relevant in every industry. I really like how it allows you to think outside of the box and be creative. It allows us to solve problems that would be difficult to solve otherwise, and it also allows us to be innovative and create new and improved methods of doing stuff. So yeah, computer science is a lot of fun and there's so much that you can do with it. The opportunities and possibilities are endless. I know that we are staying at home, so I hope that you are doing well and finding ways to have fun. For me, I have been watching Netflix, catching up on playing some fun video games, dancing, and practicing Taekwondo. So now, let's talk about what computer science actually is. Computer science is formally defined as the study of processes that interact with data and that can be represented as data in the form of programs. It enables the use of algorithms to manipulate, store, and communicate digital information. A computer scientist studies the theory of computation and the design of software systems. Computer science is such a broad topic that covers many different concepts. We can see that computer science is a fusion or combination of each of these areas: mathematics, data structures, software, algorithms, statistics, programming languages, hardware, and computer science, design, and architecture. It is important to note that there are many misconceptions about what computer science really is. Many people believe that computer science is a boring topic, and it is just the study of computers or just the study of how to write certain computer programs. Others think computer science is just the study of the uses and applications of computer and software. But this is so not true. Instead, computer science is actually a lot more interesting than what we think at first. It is the study of algorithms and their formal mathematical properties, their hardware realizations, their applications, and their linguistic realizations. So, what is an algorithm? An algorithm is easily defined as an ordered sequence of instructions that is guaranteed to solve a specific problem. For example, think of a Rubik's Cube. Have you ever solved a Rubik's Cube? There is a certain way for you to solve it, which involves you having to do certain steps in a certain order every time to guarantee the correct result. So there are different ways to make an algorithm. You can have a sequential operation, which basically serves as steps or a certain order in which you do a task. For example, first you do something, then do this other thing, and lastly, do this one final thing. You can also use conditional operations. For example, if something is true, do this. If it is false, do something else. Additionally, we can use iterative operations. When you are given a set of instructions that will be repeated, each time you finish the same set of instructions, you finish an iteration. And when you do the cycle again, you are doing the next iteration. Essentially, an algorithm is a well-ordered collection. Once you finish a single operation or step, you should always know what to do next. After completing a certain number of steps, based on what you, the programmer, decide, then a result should be produced. Note, a result can be a number, text, a light, picture, sound, or a change in the computing agent's environment. You want to be especially careful of ambiguous or unclear statements. For example, instead of saying go back and repeat, specify in detail what you want to do again and how far back you want to go. If you want to start over, specify where you are starting over from. Another situation you want to avoid is getting an infinite loop, which is usually a mistake. We will cover loops a little later in this video, but basically this means your program will run on forever, which you don't want to have happen because it essentially makes your project useless. Your goal should always be to be understood without having to explain anything in any more detail than you already have. This means that you want to be as detailed and specific as you can be. So here is an example of an algorithm. This is an algorithm for shampooing your hair. First, you wet your hair. Then you have a variable called wash count, which you set to 0. You want to lather and rinse your hair. Adding 1 to wash count each time you do so. Once the value of wash count reaches 2, you are going to stop repeating the rinse and lather steps. Essentially, this means that you can stop because you have finished shampooing your hair. Here is another example of an algorithm for shampooing your hair. First, you wet your hair. Then you lather your hair. Next, you rinse your hair, you lather it, and rinse it again. Then you stop because you have finished shampooing your hair. Note that both ways, this one and the one previous method, are both correct ways of shampooing your hair. This shows us that we can be creative and have different algorithms to solve the same problem, all of which can be correct. There is not necessarily just one right way of doing something. Congratulations on following along so far. You have officially earned your green belt. Now that you know the basics of computer science, let's begin learning some Java. So first off, it is important for us to learn about what Java is. Java is a programming language which can be used for various purposes like desktop applications, web applications, mobile applications, enterprise applications, the list goes on and on. Java is an object-oriented programming language, meaning it allows us to define a data type and its structure, along with a set of functions that are applied to it. Essentially, the data structure becomes an object which can be manipulated to have different relationships with other objects. On the left, each of these circles show some of the different cases in which Java is used. These are some of the features of Java. Don't worry if you don't understand what all of these topics are, because they are very complex. This picture is just to show some of the reasons why Java is used so commonly and why it is a good language for you to learn. Because there are so many great features of Java, Java can be applied in many places. Here are some of the major companies that use Java. Now that we have a good understanding of what Java is, let's begin learning the Java basics. First, we want to learn more about variables and data types. A variable is a memory location to store the data for a program. Think about a variable in a math equation. The variable x, for instance, can be used to represent the integer value of 3. A data type is basically the type of the value you want to store into your variable. For instance, x is our variable and 3 is the value. 3 is an integer, so its data type is int for integer. There are many different data types and each have specific uses. For today, we will be focusing on int, which is an integer, double, which is a decimal, and char, which is a character. As we can see in this image below, right here, there is an array or list of elements. There are 5 elements or people in the list, each with an index from 0 to 4. Each element stores a certain value. For instance, at index 1, the value of Laura is stored, or in index 3, the value of Caitlin is stored. Now that we know a little bit about variables, let's test it out. How do you think you could assign the value of 2.5 to a variable called num? What data type would that be? So, I hope you figured this out. This is our variable num that is type double and it has the value of 2.5. So if we wanted to print out the variable num, we should be able to get the value 2.5, which it does correctly. So we can do this with different data types as we discussed earlier. Pause the video and try it on your own to see if you can declare and initialize 3 variables, each with a different data type. So here's an example of what I did. I created a variable named val that is a type integer and that has the value of 0. I created a variable called letter that is a type character that has the value of a, and I created a variable called can_dance, which is a Boolean which has the value of true. Also, if you are hoping to follow along, if you haven't already done so, you can do so by using onlinegdb.com. Be sure to select Java as your language, and then you can write your code and compile it so you can follow along as I do these coding examples with you. Declaring a variable is as simple as saying int val. Initializing a variable means giving your variable a value, which would be, for example, int val equals 0, which means that the variable val now has the value of 0. As you can see, we must assign values on the left as variables and the values on the right as any expression or value for the variable to store. For instance, this is our variable distance, and the right side with rate times time is the expression that we are assigning to the variable of distance. Also note that it's important that you put the data type, for example, integer, then you put the name, so val, and then you can do whatever you want to it. So in this case, we are initializing the variable val with the value of 0. So the key is to make sure that you are having compatible data types. This means that you do not want to mismatch a variable declared with one data type with a value of another data type. For example, you should stay away from storing a character into a variable declared as a double. For example, here we see that the variable var is declared as an integer, but it has the value of 2.5. If we wanted to print the value of var, it would only print the value of 2, not the whole 2.5. The 0.5 would not be printed because it is not considered to be a part of the variable. It is not stored because it doesn't fit correctly. Now, I encourage you to pause this video and try putting this statement into your compiler. Again, using the online GDP website that I had previously discussed, and see the result. You should be able to print out the value 2, but not the value of 2.5. If you want to print the entire 2.5 value, what could you do to change that? Correct. Change the data type of var to double instead of int. Now, it is possible to store character values into integer variables, and it is also possible to store integer variables into character variables. This is because of a concept of ASCII characters, where each letter is assigned a corresponding number that represents it. For instance, A is the number 65 and B is 66. Pause the video and look up the ASCII table. What is the decimal value of the character M? 77. That's correct. You can also assign variables of type Boolean to integer variables. For instance, 1 is commonly used to represent true and 0 to represent false. The same applies with variables of type int, which can be assigned to Boolean variables. Another key rule is that variables of type double should not be assigned to variables of type int. However, you can do the reverse and store integer variables into variables of type double. This is like the example we previously discussed where the 0.5 was cut off of the 2.5 and the variable only stored a 2. We could, however, declare a variable of type double, for example, double n equals 2. This would essentially mean that the variable n holds the value of 2.0. This works because the variable is not losing any data, whereas it was previously when declared as an integer. This picture shows a variable to be a sort of container, and the data is what goes inside of this container. This is a great representation of how a variable can store information. So we have spent a lot of time talking about variables, and now we are going to get into what we can do with them. One of the things we can do is basic arithmetic operations. For example, we can add, subtract, multiply, and divide variables. So let's say we have this variable num and we have this variable val. We're going to change the value of val to 2. And we're going to try to do some arithmetic. So let's clean this up a little. Let's create, I'm going to change this to an integer just so it's a little cleaner for you guys, but feel free to experiment this and test it out with different data types. So I just created a variable num that is a type integer and has a value of 4. Now we have another variable called val, which is again a type integer that has a value of 2. Now I have created an integer called result. And now I want to set result to the sum of num plus val, which means that I could do num plus val. So if I wanted to print out the result, I should be able to get num, which is 4, plus 2, which is val. So this line right here should print out a 6, which it does. I encourage you to try the same thing, however, try it with subtraction, multiplication, and division. Pause the video and try it with those other operations. Also try doing it with more than 2 variables. As I just said, please note that these operations can be done using more than 2 variables, so you aren't just restricted to the 2 variables here of var1 and var2. Additionally, there are other functions we can use, like taking the power of something, finding the square root, and so on. However, we will discuss that a little later. Just as a preview, we will be using these operations shortly when we work on our calculator project. You should also consider arithmetic precision. Basically, the highest order operand determines the type of arithmetic precision you have. It sounds very complicated, but it is actually quite simple. For example, if we have 17 divided by 5, the program will print out a 3. This is because both 17 and 3 are integers, meaning integer division happens. If we simply change the numbers to decimals, meaning 17.0, and we kept the 5, the decimal is a higher order operand, which means that double division will occur, and therefore we will get the 3.5 value. So similarly here, if we have an integer and an integer, of course, if we did 1 divided by 2, we know that the answer is 0.5. However, it will just do integer division, meaning that we will just have 0 instead of the 0.5. I encourage you again to pause the video and play around with this for a little bit. These are just some shortcuts when assigning data. For instance, instead of having to type out your variable count equals to count plus 2, you could simply just do count plus equals 2, and it means the same thing. These are other examples. For instance, subtraction, multiplication, division. This is the modulus, which is used for finding the remainder. And this, again, is an example of multiplication with addition. So you can have the order of operations in here as well. Congratulations on making it this far. You have officially earned your red belt and are on your way to becoming a pro at Java. Here is a sample Java program where we can see the basic outline of what there is in a simple Java program. Firstly, we have a class called Hello World. And everything that is inside of this pair of squiggly lines, so this box here, is a member or part of the class. For every Java program, you must have a main method. And this line, public static void main string args, is the correct syntax that you should always use. Within these braces, you can write whatever code you want based on whatever you are trying to do. For example, here, this code prints out the words hello world. To print something out, we always use the syntax system.out.print or system.out.println if you want to start on the next line. Then we have parentheses and quotations, putting whatever we want to have printed inside these quotation marks. Then we need to end the line with a semicolon, otherwise the code will not compile and it will tell us that there is an error. For instance, if we get rid of this here, this semicolon, we will not be able to run our program. It will say error semicolon expected. So if we add that semicolon, we will be able to run it correctly. Another key concept is input and output. It is pretty self-explanatory. Basically, the input is what you were putting in, and the output is whatever will be outputted, or whatever the result is. For example, here, if we put in 60, we can perform some sort of thing to it, like multiplying it by 10, and output the result, which gives us the 600. Essentially, we put something into our program, which is our inputs. The program does something to it, it processes it, and finally it returns us the output or the result after the process. Another topic is Boolean expressions, in which we have logical operators representing and or. We can also have the data type of bool, Boolean, which simply returns either true or false. For example, we can have or, and, or not logical operators. For instance, we can have puppies and kittens. We could have a puppy or a kitten, or we can say that something is not a kitten, so it is a puppy. When making comparisons, we can use any of these symbols for Java notation. For instance, if we want to say that something is equal to something else, we can use this. So we could say x plus 7 is equal to this 2 times y. Or we could say that the variable and is not equal to this character n. So we could also do the same thing with less than or equal to, greater than or equal to. For instance, we could say that the time is less than or equal to the limit. Now we will look into branching mechanisms, specifically the if or else statements. Basically, this structure allows us to say, if something, do this, else do something else. For example, if we have white cream, then we want to eat. Else, if there is no white cream, we leave. Notice that this else is optional. We could simply just say, if white cream, then eat. Also, you want to be careful when you have multiple things to do. For example, you could say, if white cream, eat, wash hands, and drink water. Each of those steps only happen if you do have white cream. So you need to put all of those instructions within these braces. You use the braces when you have more than a single line of code for that specific condition. So now, let's do an example of this. We could say, if num is less than 5, we want to print out result. And then we could say, else we'll print out here. instead of doing that, we will just say, I'm going to comment these out. So when we want to comment something out, we just do 2 slashes, and basically it comments out that line, which means the program won't read it. And usually that's really helpful for us to understand, like if we have a lot of code, what a certain line or something means when we want to look back at it, but it doesn't interfere at all with any of the functions of the program. So right now we have this int num equals 4. So we're saying if num is less than 5, we're going to print out num is less than 5. And then we'll say else it will print out num is greater than 5. So what do you think this is going to print out? It prints out num is less than 5 because this condition is met, and therefore this does not happen because it's an if or else. So only one thing will happen. Now, we could simply just have this if. So like I said earlier, we don't need to have the else. So if we comment that out, it will just print out this num is less than 5, like what we had done earlier. Now we could also have more than just the if and else. So we could also have another condition. We could say if num equals 5, then we could print out something else. We could say num equals 5. So this tells us that if num is less than 5, we want to print out num is less than 5. Or if that's not true, then num could be equal to 5, in which case we want to print out num equals 5. And if neither of those conditions are met, then we will print out num is greater than 5. Now, another possibility that we could do is we could do multiple things within this if statement. So as we've already established, we know that num equals 4, which means it's less than 5. So if we want to print this out, it will still do that. Now I added these braces so we can do more stuff once this condition, if num is less than 5, is met. So we'll do num plus plus, num plus 3. So this num plus plus is going to increment the value of num, which means that num will then be 5, and then we're going to increment that by 3 by adding 3 to it. So let's see what happens to that. Sorry, we need to do the plus equals because we still have to assign that value to num. So now, once we increment num and then we add 3 to it, we're essentially adding 4 to the value of num, and then we're going to print out num. So we're going to print out the value of num. So once we do that, we get 8. So now if we wanted to play around with it, and let's say we did not have these braces here, what do you think would happen? Well, let's run it and see what happens. Well, I just commented out these lines as well, so we wouldn't have to worry about any errors or fix that code right now. So if we got rid of those braces, it's still going to do these operations. So we still essentially get the same results. However, let's say we changed this to if num is greater than 5, which it's not. Remember, num is equal to 4. So this condition is going to fail. What happens? Well, it does not print out this num is less than 5, but it will still perform these operations because these operations are not considered to be part of that if condition anymore. Since we got rid of those brackets, they're not connected anymore. So that might be a lot for you. I encourage you to pause the video again and try it on your own. Play around with it for a little bit and see if you can make some changes to it. Tweak it a little and see what the braces mean and see if you can add some other conditions to your if and else logic. So now the last major topic we will be covering is loops. There are 3 main types of loops, which are the while loop, do while loop, and for loops. A loop basically means that you perform whatever operations are within the braces of the loop as long as the condition is met. For example, in this for loop, it will print out the word hi 3 times. This while loop does the same thing, printing out hi 3 times as well. Do notice that these examples say cout instead of the system.out.print syntax we discussed previously. These pictures are actually using C++ syntax, so be careful that you are sticking with the Java syntax we discussed already. I encourage you to pause this video and try this out for yourself. See if you can get your program to write your name, to print out your name 10 times. And remember, be sure to use the Java syntax of system.out.print. So now we are officially at the point of beginning our coding project. Now that you know the basics, let's begin coding. We will be creating a simple calculator. Use the link provided to type your code and follow along. I encourage you to take times throughout the video and pause or rewind to test things out on your own and play around with it so that you can get a better understanding of what things mean and why you are doing them. So with that being said, let's get started. So we are going to begin coding our calculator project. So I'm going to get rid of the stuff that we had done previously and we're going to start fresh. So first, this is kind of the outline of our program. Again, this is the basic structure that we had kind of discussed, meaning that we have the class. These are our braces. Whatever is within these braces are part of the class. And then we want to have a main, which is here, the same syntax that we talked about previously. And I also just called this class main. So we're going to begin by this line here, which is import java.util dot with the little star and the semicolon. Now, this line of code is basically a package that allows us to access a collection of classes and methods within a certain framework that is already defined for us in Java. So it allows us to have access to certain functions without having to write them from scratch ourselves. And that makes things a lot easier. And we'll talk a little bit more about that as we go through. But an example of that would be the power function. So earlier in the video when we were talking about the arithmetic operations, and we were talking about adding, subtracting, multiplying, and dividing. And I said that there are other things that we could do, for example, taking the square root of something or whatever. We could get access to those functions by importing them, so we don't have to write them ourselves. So if you're interested in that, I encourage you to search up this line of code and see what functions and classes are already defined for us, so we don't have to write them ourselves. So with that, let's get started. So the first line of code that we're going to do is going to be a scanner. So I'm going to call it scanner in, and we're going to do this line. Now, in is the name of our variable, and in is a scanner. And then this is just the syntax that you use when you're using a scanner. And basically this goes back to the topic of inputs and outputs that we were talking about earlier. So our program is a calculator, which means that we want to allow the user or the person who is using this program to be able to input certain values or numbers that they want to have be calculated. So we need a way for us to retrieve these numbers, these values that the user wants us to calculate with. And we use the scanner to do that. So I'm going to create variables A, B, and C that are all type double, and I'm going to initialize the variable to have 0. So it's 0.0. Now we're going to print out a statement. So we're going to do system.out.println. Then we're going to have the parentheses and our semicolon. Print, spelled that wrong. All right, so something to notice is previously when we did our system.out.print, we did not have the ln, and the ln basically just means next line. So I encourage you to kind of play around with that as well and see how when you run things, if you put the print ln or you just have the print, how that makes it look a little different. So we're first going to print out a welcome. So we'll just say welcome, enter the values for your calculation below. So basically, this means that when we run this, it should just output this. Don't want that typo, sorry. It should just run this and print out that statement. So tweak it however you want. You can have it say welcome, you can have it say hello, whatever you want it to say, feel free to play around with that. So I'm just going to copy this and paste it so I don't have to retype that. But now we're going to try to just get rid of that ln, so it just says system.out.print. And then we're going to print out a new message, so we will say first number. So basically, I want it to print out first number, and I'm basically trying to prompt or tell the user to enter a number. And then whatever the user wants as their number, I'm going to make that value be stored in the variable a, which I have already defined previously here, right? So the way we do that is we say in.next double, like that. And this is another syntax that we use when we are using scanners, and because a is defined as a double, we have next double. So you could have different next integer or whatever based off of the data type that you are using. So for instance, if we were to run it now, it would prompt the user to put in a number. So let's say the user puts in the number 8. That means that now a has the value of 8. So since this is a calculation, we want this to happen another time at least. So we want to at least have 2 numbers to calculate with. So I'm just going to copy those 2 lines, and then we're going to say second number and change this to b. So a is going to represent the first number the user puts in, b will be the second number, and then we will have c represent the result, so whatever they choose to do with those 2 numbers. For instance, if they wanted to add a and b, then c would be the result of adding a and b. So now I want to have another print statement, and I think what I would like to do is let's have it say the functions of the calculator. So let's have it say calculator functions, like that. Now let's do things a little differently and let's concatenate. So we're going to add something to it. So notice that we're still writing within the parentheses of the same print statement. All right. So we're going to add to it, and we're going to do a \n, and then we will do this 1 to add, and we will do another plus. Now, I am not going to reveal this to you at the moment. I want you to think about it, and in a little bit, when we run the program, see what happens and how it's formatted, and think about what this \n could mean. Once you've thought about it for a little bit, try searching it up and see if you got it correct. So I'm just going to copy this line here, and we're going to paste it. So we have that 4 times, and then I'll do 5. And I'm just going to do 2, 3, 4, and 5. So this is a pretty simple calculator, so we're just going to have 5 basic functions within our calculator. So we're going to be able to add, we will subtract, we will multiply, divide, and then we will do one that allows us to take the power of something. And I'm adding more of those backslash n's, so please be sure that you're thinking about what that could possibly mean. Just to keep things interesting, you know, don't want to reveal everything. So here we go. So basically, here we have quotations and a single line within this parentheses. Now, in this set of parentheses, we have quotations, then we have a plus, then we have more quotations and a plus, more quotations and a plus, more quotations plus, etc. Basically, what this does is it's going to print out whatever is in that set of quotations. Then it's going to print out whatever is in this set of quotations, and so on. So let's run this and see what happens. So it asks us to put in the first number, so let's say we put in 4. It asks us for a second number, so let's say we put in a 3. And then it just shows us the calculator functions, so it prints these out. So in case you didn't see already, the backslash n brings you to the next line. And here, since we put 2 backslash n's, it brings us 1 line and 2 lines. So it kind of skips to 2 lines. So moving along, it ends off with it asking the user to enter a choice. So when it says that, we want the user to enter a choice that is from this 1, 2, 3, 4, or 5, and basically that's going to tell us what the user wants. So let's say the user puts in a 3. That means that the user wants us to multiply their number of 4 and 3 to result with 4 times 3, which will produce the result of 12. So how do we do that? We will create another variable called double something. And we're going to do the same in dot next double. And again, remember this syntax is just what we need to do when we're trying to use the scanner. And again, we're using the scanner as a way to kind of get the input from the user. So I'll say double addition equals 1. Double subtraction equals 2. Basically, we're going to be assigning number values to these variables that we are creating. So I'm creating the variable addition and assigning it the value of 1. And basically, this is going to kind of represent the option choice of 1, which indicates that the user wants to add. So I encourage you to pause the video really quickly and declare and initialize the variables multiplication, division, and power. So if you paused it and did it yourself, these are probably what you did. And you could have named your variable something different. I chose to kind of do something meaningful so we understand what it means. And basically multiplication equals 3, division equals 4, power equals 5, and they are all the data type double. So now that we have that established, we want to do stuff with our variables. So we will use some of that if, else logic that we had discussed earlier. So if something, which again represents the user's choice of which operation they want to use, so if something equals to 1, what does that mean? That means that the user wants to add, right? So let's say if something equals addition, then we will perform addition, which means that we're going to take the numbers that the user gave us, which again are in A and B, and then we're going to add those two values together, and we're going to store the result of that sum into the variable C. Then we're going to print that out. So let's do a print statement that allows us to do so. I'm just going to copy this. So we have that print statement, and then I'm just going to write what we want to write in there. So basically, I'm going to say A plus, and then I'm going to do a plus with spaces on both of sides of it, plus B plus space equals space, and then I'm going to put C. Now, think about what this means. So this is going to print out what is exactly in those quotation marks. So it's going to print out the spaces and the plus sign. Same goes here. It's going to print out the spaces and the equal sign. Now, there are no quotations here, but why does that work? That's because I want to print the exact value of variable A. I don't want to necessarily print out A itself, so I'm not looking for it to print out the alphabet A. Instead, I want it to print out the value of A, which is whatever the user's value is. So let's run this and see what happens, for instance. So just really quickly, let's say the first number the user puts in as a 1, the second number they put in as a 3, and they select 1 because they want to add. So it's going to do 1 plus 3 equals 4. So it prints out the value of A, then it prints out the space plus the space, then it prints out the value of B, which is 3, then it prints out the space, the equals, the space, and then the value of C, which is 4. So if you wanted to play around with it and see what happens if you take out the space and you run that, go ahead and do so. I think that would be a fun thing for you to look into. So now we're going to do, we already did the function for addition, so now let's move on to subtraction, multiplication, and division. They're all going to be very similar with the exception of the fifth one, which is the power. So I highly encourage that you pause this video and you try to do the subtraction, multiplication, and division by yourself. Then I will reveal the answer and you can check if you did it correctly. Remember, you can also check if you did it correctly by running the program yourself and seeing if it does the work correctly like you intended. Once you're done with that, we will move on and discuss the power function, which will be a little different. All right, so I hope that you were able to pause and try to figure out the subtraction, multiplication, and division yourself. This is the correct solution, and it kind of just follows the same format of what we did for the addition part. Notice that I added the else before each of those, which basically says, like, if it's this condition, we're going to do whatever is within those braces. Else, if it's this condition, we'll do whatever is in these braces. Else, if it's this condition, whatever is in these braces, and so forth. Notice that we are changing this line here based off of whatever the operation is. So for instance, here we are doing subtraction, so the value of C is A minus B. Here we're doing multiplication, so C is going to be equal to A times B. And here we're doing division, so C is going to be equal to A divided by B. Notice in our print statements, we do not want to change these pluses because those do not indicate addition. Those are used for the print statement and the print statement only. So these quotation marks are where we want to change it. So we're going to change this to show minus, this is going to show multiplication, and this will show the division. So if we round this, for instance, and we chose to multiply, so that was the third option, and we had the numbers 6 and 2, we would be able to see 6 star 2, which equals 12. And again, the star represents multiplication. So now we're going to do our final one, which is the else. If something equals to power case. Now, this one is a little different because we're going to be using a function that we inherited earlier. So, first of all, we want to consider what taking the power of something does. So we have two numbers, so we could either do A to the power of B, or we could do B to the power of A. So we want the user to specify which case they want to do. So this means that we want to have some sort of scanner, again, another variable that allows the user to have that input and indicate to us and the program which one they want to do. So pause the video and try to create your own new variable that's going to implement this scanner. So here's what I did. I created a print statement that's basically going to ask the user what we want to know. It's going to tell the user that we want more information as to what we would like to take the power of. Essentially, it will tell the user to either input a 1 if they want to take the first number to the power of the second number, or enter a 2 if they want to take the second number to the power of the first number. So what we did was we declare a variable called power of, again, that is a type double. We're using the scanner syntax, which is going to allow the user to give us an input value that we're going to store in power of. So if we were to run this, and the user input the values of 4 and 5, then they select option 5, meaning they want to take the power of something, then they would be able to get this message which says, would you like to take the power of? Which one? Then it would output 1, take the first number to the power of the second number, or 2, take the second number to the power of the first number. And then they could input 1 or 2. So now that we know this, we want to use that if-else logic again. So depending on what the user has decided they want to do, we're going to do a certain thing. So for instance, if the user selects 1, that means they want to take the first number to the power of the second number. So how would we do that? I encourage you to pause and try to write your own if-else statements and see if you did it correctly. So this was a little bit of a challenge just because, like I mentioned earlier, we want to use the math.pow, which is a function that is predefined for us because we already inherited that from this import statement that we did earlier. So you probably did not know about that. However, you could have still figured out the if or else logic. Now, the reason why there is no parentheses and whatever information in here is because there's only 2 cases. So either the user inputs 1, in which case we're doing this, or they put a 2. So it's either it's a 1 or else you're going to do the second option. So this right here means we're doing a to the power of b, and this means we're going to do b to the power of a. So if we ran this, assuming we had the values of 6 and 3, assuming that the user wants to take the power, and the user decides to take the power of the second number, 3 to the power of the first number, which is 6, we would do 3 to the power of 6, which gets us this value. So we have officially finished creating our calculator. Now, if we were to run this, we should have a working calculator. So we get our welcome statement, and then the program prompts the user to input a number. So the user could input 10, and a second number, let's say we did 8. Now the user is able to see the different functions within the calculator, and we're able to make a choice between 1 through 5 to decide what we want to do. So let's say we wanted to subtract. We could subtract, and we should be able to get 10 minus 8 equals 2. So it works correctly. Make sure that you try out the different functions of your calculator to ensure that all cases are working correctly. I encourage you to play around with the code that you have now, since it works, and try different things. Try writing different statements, try mixing it up with print, println, and so forth. Just try messing around with it for a little bit and see what happens. See what happens if you comment something out instead of having that variable and you put a 1 here. Does that change anything? So play around with it and just have some fun with it. Essentially, this wraps up our first segment for this Intro to Java Programming workshop. Be sure to watch and follow along with the second video to go a step further and create a more advanced tic-tac-toe game. We will also learn more about what a potential career with computer science could look like. If you have any questions, feel free to reach out to me at the email provided below or at Pasadena City College's PCC STEM. Thank you for your time and for following along with me today. I hope that you are staying safe and healthy and continue to keep learning and be creative. Remember, computer science is all about thinking outside of the box. See you next time.